In this problem, we are going to construct a mathematical model, the least square approach, to predict one variable. In this case, reaction time. We are going to predict this variable using the other variable, percentage of drug received. Consider the straight line model, expected value of y, where y is the reaction time in seconds, equal b sub 0 plus b sub 1 x. This is the equation of a line in algebra. And x represents the percentage of drug received. A. Use the method of least square to estimate the value of b sub 0 and b sub 1. B. Predict the reaction time when x is equal to 2%. C. Find the sum of a square error for the analysis. And D. Give practical interpretation of b sub 0 and b sub 1. I strongly recommend to do all of these problems using technology first. And after that, you must obtain the same answer using formulas. Then this is the data. We can send this data either to StatCrunch or to Excel. You have to send this data in both sides. It doesn't matter if it's only 5 pair of number like this or 100 pair of number. You will spend the same time doing one problem like this or another problem with 100 data, 100 pair or 1 million. It's the same, approximately the same time. There is no big difference. When you send this to StatCrunch, let's obtain this answer. I am going to explain you how can we obtain this print out from StatCrunch. And let's go to StatCrunch. In StatCrunch, we send the data automatically, and we need to go to Stat. And in Stat, you have to go to Regression, and simple linear regression. Then my x variable is my predictor, or the independent variable is located in this column, percentage of drug. The response variable or dependent variable will be located here, reaction time. That's it. When we click compute, we obtain our data. You can use all of these numbers to answer your question in MyStatLab, and that's it. You have not done anything. But you need to show your work. You need to obtain all of these numbers using formulas and tables. And also here, you can obtain the graph. When you click here, that is the graph of this mathematical model. The equation of this line predicts y reaction time in terms of x. For 4 is approximately this, for 2 is approximately this, but these are my sample. If we obtain all possible value, it's possible that around this point we have a cloud of points. How can we obtain all of this number using Excel? Let's send this information to Excel. We have this information in Excel already. Then, first of all, remember we need to obtain the equation of this line. We have several points. Then the equation of this line in algebra will be given by something like this. We are going to estimate the value of y when x is given using this formula. B sub 0 estimated plus b sub 1. We are going to estimate also this slope times x. Then given any x, we are going to obtain the corresponding value for y. Okay, then how can we obtain this number and this number? First of all, we need to compute b hat, b sub 1 hat. The formula for b sub hat what is given by the sum of a square of xy divided by the sum of a square of x. And how can we obtain b sub 0 hat estimated? Because the actual equation, when we deal not with few observation, with the all possible observation in the population, this equation, it must be written in this way. Y is no estimator, b sub 0 plus b sub 1 x. Then that should be, this is our objective. But it's impossible to obtain this if we don't have the data from the entire population. We are going to use sample. For that reason, we need to write all of this value estimator. When it's given 1x, then y is estimated, b sub 0 is estimated, and b sub 1 also. Then b sub 0 could be obtained using this formula because this point, the center of this mathematical model, corresponds to the mean of all x and the mean of all y. The mean of all x must be located in the center of this line, and the mean of all y also should be located in the center of this line. This point, x bar and y bar, must satisfy this equation. We substitute y bar and x bar here in this equation. If we want to isolate b sub 0 from this equation, we obtain b sub 0 hat is equal y bar minus b sub 1 hat x bar. Then we have b sub 0 and b sub 1. With these two numbers, we can obtain this equation. But how can we obtain the sum of a square of all x? This formula is very simple. We need to obtain the deviation of all x, all these values, all x, respect to the mean of all x. We are going to square all of this deviation and add all of the deviation. But we have a shortcut formula for this. The shortcut formula is the sum of all x squared minus the sum of all x raised to the second power divided by n. The same thing for the sum squared for all xy. In this case, we are going to obtain the deviation of all value respect to x, all of these x respect to the mean of all x, multiplied by the corresponding deviation of, for example, for this value, the deviation of this value respect to this, and the deviation of the component y respect to this other number. For all of these points, we're going to do that and multiply both deviations. Then there is a shortcut formula also for this sum of a square for all xy is equal the sum of a square for all x times y minus the sum of a square of all x times the sum of a square of all y divided by n. How can we use Excel to find all of these values? First of all, we need to go in this place to obtain the sum of all values from this point to this point, close parenthesis. And also, we are going to obtain the sum of all of these columns. Let's copy this formula in all of these columns. Then also, we have obtained the sum of all y. How can we obtain the sum of all x squared that we needed here? Then first, we need to obtain the square of the first value of x raised to the second power and copy this formula in all of these cells. Then we have the square of all value of x, of all x. Let's do the same thing for y. Equal the first value of y raised to the second power, and we copy this formula in all of these cells. Then we have the square of all y. And how can we obtain the product of each component of each pair? We need to multiply the first, this is equal, the first x times its corresponding y. And we are going to do the same procedure for all pairs. And that is the sum. After that, because we need the sum of all x squared will be obtained equal the sum of all x squared that is located here minus the sum of all x that is located here raised to the second power divided by n. In this case, n is 5. Let's do the same for all y. We don't need it in this problem, but let's compute also because we need it later. The sum square of all y, we need to obtain for each value of y the deviation respect to the mean and square this quantity and sum all of the deviation square. This is the shortcut formula. The sum of all y squared minus the sum of all y raised to the second power divided by n. The same formula for all of them. This deviation is equal the sum of all y squared minus the sum of all y raised to the second power divided by 5. Let's do the same for the sum square of all xy. How can we obtain that? Using this formula, this shortcut. Then is equal the sum of all xy, x times y, minus the sum of all x times the sum of all y divided by 5 also. And what is the formula for b sub 1? Formula for b sub 1 is the sum of a square of all xy divided by the sum of the square of all x equal the sum of the square of all xy is located here divided by the sum of the square of all x. How can we obtain b sub 0? We use this formula. Then first we need to find the mean of all x. The mean of all x is the sum of all x divided by 5. And the mean of all y is equal the sum of all y divided by 5. Okay. Then b sub 0 is equal the mean of all y located here minus b sub 1 that is located here time x bar. X bar is the mean of all x. That is b sub 0. Then we can write the formula. The formula, this formula, that is the actual formula, but this is the formula estimated with this sample. Y, the expected value of y is equal b sub 0, which is negative 0.1 plus b sub 1.7 x. That is my mathematical model, obtained using this sample, only 5 observations, 5 pairs. Then that is the way that we need to show your work. That is the formula. Can you see here? This is the formula obtained in StatCrunch. This is b sub 0, y-intercept. That is the slope, b sub 1 hat 0.7, and that is the graph. You can do the same problem using the original formula, not the shortcut formula. And this is in Excel, the worksheet in which we use the original formula, not the shortcut formula. And that is using the shortcut formula. And we obtain all of this value that we needed. We need all of this value to obtain the mathematical model. If you want to use the original formula, all x are located here, or y here. Then we need to obtain the deviation of all x with respect to the mean here in this column. The deviation of all of this y with respect to the mean, y bar, are located here, here. And the product of all deviation is this value times this value times this value, this. And the deviation of all x squared is this column, and the deviation of all y squared is this value. Then we can use the original formula in this way. We can do the same thing in Excel. You can do it in this way, but I recommend to you use the shortcut formula that is easier. That is the original formula. The sum of square of all x, y is given by the product of the deviation of x and y for each observation. When we sum all of this, the product of all of these deviation using Excel, we can obtain this value. And we can obtain the same value using the shortcut formula. When we use the shortcut formula, we obtain the sum of all xy. Using either procedure, we will obtain the same formula, but I strongly recommend use the shortcut formula. Then the slope is given by this formula, and the equation of the line is given by this. We already did it, and that is the graph. You can copy the graph from StatCrunch. That is your work. You need to show your work in this way. And if you add the worksheet in Excel, will be considered as an extra credit. Then how can we predict the value of y for a given value of x using our mathematical model? In this case, when x is equal to what is the predicted value for y? Then we need to substitute x, this value of x, here. Then when we substitute, we obtain the expected value for y. When we apply 2% of this drug to any patient, to one patient, we expect this value of 1.3. The reaction time is 1.3. However, in our sample, I think that for when x is equal to, the reaction time for this patient, this particular patient, was 1. But if we apply to all patients this percentage, the average of all of these values should be 1.3. Is the average, my expected value. And the sum of square of all error is given by this formula. Let me write this formula here. The sum of square of all error we need to obtain from the mathematical model. This is the mathematical model. We have all of these points. In this case, we have a few points. This is my model. The error in this case, respect to my model, is this distance. Because when x have this value, according to my model, that is the expected value. That's the expected value for y. The expected value for y. But in this sample, when x have this value, y was this. That was the reaction time. Then this difference between these two numbers, that is the error in my estimation. Then when we sum all of these errors, so this is one error is given by y minus y hat. When we sum all these square, when we sum all square error, we obtain the sum of all square error. For this particular formula, we have a shortcut also. Remember that this value here could be written as this. This value given xi, this is for all I. This is yi, particular observation, x sub I. This is y sub I minus the expected value when x is equal x sub I. Then this value will be b sub 0. Let's use here b sub 0 plus b sub 1 hat x sub I. This is the actual difference between my model and the observed value. When we do that, there is a shortcut formula. The shortcut formula for the sum of square error is given by the sum of all y, sum square of all y, minus is very similar to the minus b sub 1 hat, the estimation of b sub 1, times the sum of square of all x, y. This is the shortcut formula. You can do this in Excel using this or using the original formula, but it's too long. It's a too long procedure, but you can do it in Excel. But I recommend to use the shortcut formula to obtain this sum of a square error. With this sum of a square error, we can obtain later the standard deviation of my model of all error. Let's erase that. Then how can we interpret b sub 0? B sub 0 in this case is this constant. Then that is the intersection with the axis, the y intersection. When x is equal 0 in this mathematical model, then y should be equal negative 1, negative 0.1. But remember, y is time. Time never is negative. Actually, doesn't make sense, this value. Then for that reason, so we don't consider 0 in our range of possibility for x. And the interpretation of b sub 1, this is the slope. This is the slope of my straight line. And remember the definition of slope in algebra. In the slope in algebra, if you have this value and this value, then is the difference of all y, remember, y2 minus y1, divided by the difference of all of the first component, x2 minus x1. That is the slope. And you can interpret the change in y for each unit of change on x. When you do this division, when you do, for example, when you divide 40 apples between 20 children, is 2 apples per children. Then for each unit in the denominator. The same thing here. When we do this quotient for the slope is the quotient for the increase in y divided by the change on x. When we move from one point to another point, that is the slope. Then we can interpret the slope, the change in y for each unit change on x. Then in this case, this 0.7 could be interpreted the change in the reaction time 0.7 for each unit in percentage of this drop. When we increase the percentage of this drop in 1%, the change in the expected value for y should be 0.7 seconds. To obtain R, the correlation coefficient, determination coefficient, and all these values, this value will be very important. And we are going to explain this in the next slide. How can we use Excel to find all of these values?